Look at the first example here. We got a solution of sulfuric acid, right? Sulfuric acid is H2SO4, all right? And we add it to a solution of barium hydroxide, right? So BaOH2, all right? And right, these ones, if we do our little double replacement here, like this is kind of a classic double replacement reaction. You have a strong acid and a strong base, right? You would get barium sulfate, right? And H2O, right? But something that normally what I would do here is when we write our net ionic equation, we want to get rid of ultimately all of our spectator ions and stuff and get down to the nitty gritty, right? Okay, so is sulfuric acid a strong acid? Yes, right? So we break that up into its ions, right? You would write it as H plus and SO4 2 minus. Is barium hydroxide a strong base? Yes, it is, right? So the barium has this ion and a hydroxide ion, right? Okay. So then ultimately we get our products out, right? We've got barium sulfate. That guy's soluble, insoluble. What's the story with that one? Barium sulfate. It's insoluble, right? That guy's a solid, right? So we split him up. Nope. Okay. Write him as barium sulfate solid. And we got liquid water, right? So H2O we leave together as well, right? That's a liquid. Okay. And then we just got to make sure that we have everything balanced, right? Okay. Cross out any spectator ions and stuff. Do we have any spectator ions here? No spectator ions, right? Is everything balanced? I mean, right now it's balanced, ionically it's balanced, right? Like when I write this one here, this one kind of bothers me, right? Right, because H2SO4 and right, barium hydroxide. I want to write out as right. I want to put like that stuff in there. Miss Mars, am I making a mistake here? This net ionic equation. We're okay, right? Yeah, right. It's all right. Even though in the first formula, it just makes me feel like it's not right. You know what I mean? Because in the first formula here, we got 2 hydroxides, but we just break it up into its ions. This guy's still all balanced, right? And we're good to go.
I think it's wrong to put like a 2 and a 2 and then a 2 in front of the H2O. Like you could put a 2 in front of the H plus and then 2 in front of the OH minus and then you have to put a 2 in front of the H2O. I think you can also do that, but you're still combining it at 1:1 ratio.
Right. Yeah, so you can leave it like that, or you could also do this. Do that if that makes you feel better. That way it kind of makes me feel better, but it doesn't matter.
I would think they do either.
Mm-hmm. It's balanced either way. All right. So there you go. So there's, whoop, what just happened there? So there's an ionic equation. That one. All right. So we have hydrogen sulfide gas is bubbled through excess potassium hydroxide solution. Okay. So you've got hydrogen sulfide gas, so that's H2S, right? And it's a gas, so I'm going to get rid of this gas. And we have potassium hydroxide, KOH. right? With obvious potassium hydroxide is our base, right? Hydrogen sulfide is going to be our acid here. Okay, so we do a little double replacement. We end up with K2S and H2O. Right? It's because H2 hydrogen sulfide is a gas. We're going to write that guy and leave it together. Right? Gas is KOH, a strong base. Right? So we break that into its ions of K plus and OH minus. Is potassium sulfide. Is that guy soluble or insoluble? Soluble. Okay. All right. That guy's soluble, so that's K plus and that's 2 minus. And water we leave together. Okay. So do we have some, do we have spectator ions here? All right, we want to get rid of our spectator ions. So we can get rid of K plus. All right, and then ultimately you got H2S gas and hydroxide ions. We're going to form sulfide ions dissolved in solution and water. So there you go. All right. So if you want to, you can kind of skip the first step that I'm doing and kind of jump to the spot where you're just looking at the ions, okay? But I'm just going to keep writing them in kind of like 3 steps here. All right, so sulfur dioxide gas is bubbled into an excess saturated solution of calcium hydroxide. Yeah. Oh, I'm not balanced. Yeah, thanks. Yeah, we got more hydrogen over there. We got to balance this guy. We got to do the balance. We're going to need a 1 action. We're going to need a 2 here, right? And then a 2 hydroxide. Like that. That works. Right. Thank you. Okay, so for this one here, this is kind of a tricky one, right? They have SO2 gas, right? Remember, if you look up there, sulfur dioxide gas bubbled through water is going to make H2SO3, right? So that guy is actually making, you want to write that guy as H2SO3, right? Because it's being bubbled through solution. Solution made of water, all right? And then we have calcium hydroxide. And what are our products here? SO3 and water. Great. Okay, is H2SO3 a strong acid? No, it's not. All right, so we keep it written as is. Is calcium hydroxide strong base? Okay, break that up into ions. Calcium sulfite. Okay, soluble, insoluble. Soluble, right? Am I right now? I think so. Oh, I got it. Okay. Oh, wait a second. She's not here today. Sulfite. Is calcium sulfite soluble, Miss Mars?
I would say no, based on our solubility models, right?
It's not on our chart,
So then no.
so it's not.
Not on the chart.
It's not soluble. All right.
You have to look up the KFC of it.
No, that's all right. I believe it. We're all good.
And we know KFC.
All right, so we got calcium sulfate.
KFC is 6.8 times 10 to the minus 8. So
I say no. All right. So do we have any spectator ions to cancel out? Nope. It's balanced. Nope. Right. Sulfate. H2, 2, nope. What's in here, don't we? For the hydroxide. And we need a 2 in front of the water, right? There we go. All right, guys, balanced. We're all set. Wait, do you guys not have one more down there? On the front page? Oh, it's on the next one. What? Oh, it's on the next page. All right. All right, so ammonia. All right, so here we go. Let's get going. So ammonia is NH3. And we got hydrofluoric acid, so HF. All right, so which one's the acid, which one's the base? Yeah. Okay, so and what will be our product, do you think? What do acids do, Bronsted-Lowry-wise? They're donators, yeah. They're donating hydrogens, okay? Bases are accepting them, okay? So this is a little different. So in this case, right, we know that this HF is the acid, right? It donates an H. This guy's going to act as the base. Ammonia is acting as the base here. So this is where those amines kind of act as weak acids or weak bases. Okay, so if you see, when I'm talking about an amine group, I'm talking about a group of nitrogen. Okay, if that nitrogen group or the nitrogen compound is uncharged, it will act as a base. And the other compound that you're looking at there is going to act as an acid if you're not sure. Okay? Right? So in this case, though, you know that HF is an acid because it's got the hydrogen out front. You know that it's going to donate to H. So the other guy, so NH3 becomes NH4, the positive charge. Because it just gained an H plus. And if you remove that H plus from HF, there you get chloride. Okay. And so that's our balance equation there. And just to kind of look at these again, on the other side, right, if we go back the other direction, right, remember we talked about, we're not talking about them yet, but like conjugate acid-base pairs, you guys remember some of that stuff? Or at least recognize, like, I've heard that word before, okay, conjugate acid-base pairs, right? So if one substance acts as a base on one side of the equation, well, this is its conjugate acid on the other, okay? And the fluoride would be acting as the conjugate base then at that point, because if you go back the other direction, F would be the proton acceptor, so it's acting as a base, and the NH4 would be the proton donor, because it's acting as the acid. Okay, so on the product side, we just call them the conjugate. All right, so you notice they're pairs though, right? Nitrogen, NH3, it gained the hydrogen. So it's a base on one side, acid on the other. So that's it. That would be a conjugate acid-base pair. Or HF and fluoride are the other conjugate acid-base pair. We get that a little bit later. All right. Those are just different examples there. Okay. And yeah. All right. At this point, we can do a couple of different things here.